Thank you. This is a quick sketch of the talk. I'll start out by talking about sentiment analysis proper. The title's a bit misleading. I forgot to edit it because I'm not going to have time to talk about all of these things. So I'm not going to talk about intent and risk or the demographic profile stuff we've been playing with, but I will talk about deception and emotion, and then some example application areas, some of which are in politics. First of all, let me say how we do this kind of stuff. We use a range of techniques from computational linguistics or natural language processing. We use some fairly intuitively obvious things like pattern matching, which is based on doing some kind of linguistic analysis of the text so that you reduce some variation. You can pick out particular phrases and words. So, for example, a particular thing that we do quite a lot of, I'm not going to talk about today, is something called information extraction, which is the process of going from unstructured text to structured records. For example, you might want in the finance world to keep track of personnel changes in the FTSE 500 companies or something. So you look out for patterns, for texts that match a pattern like this, where some person moved on from some company role. We can do that reasonably accurately. When I say reasonably accurately, that means it's nowhere near perfect, but good enough to be useful. We use lots of machine learning methods, traditional classifiers, which are ways of automatically assigning labels to text based on a training corpus of data. Currently fashionable ways of doing this are the so-called deep learning revolution, which you probably read about in the press, lots of hype about it. It's works in natural language processing. It's widely used and gives you a little bit better performance than traditional methods, whereas in other areas like speech and vision it does give you significantly better performance. What methods you use really depends on how much data you've got, in particular annotated data. So this is data where the texts, some individual, some human, has gone and annotated the text with the labels that you're trying to predict. And in our case, these people are typically linguistics students who are very happy to do this for money. You need a lot of it though, so it's expensive and takes a lot of time to acquire. I'll talk briefly about a way of trying to get around that. What is sentiment? Well, sentiment proper is the detection of positive, negative, or neutral attitudes expressed in text. So this is an attitude which is implicitly associated with the author of the text. Here are some simple examples. So the stuff in green, I think if you read that, you'd say that's an unambiguously positive statement about the film. Whereas the one in red, I think you'd say was unambiguously negative. The one in blue is actually neutral because it's not expressing an opinion at all. What it's doing is giving you a couple of nuggets of the plot. But it actually contains a couple of words that in isolation you might well think have negative connotations, like breach and rogue. And actually my guess is that most automated systems would classify this sentence wrongly. They'd classify it as negative on the basis that it contains those words. But if you think about it, it's not negative, it's because it's not expressing an opinion. So that shows you that this is not a completely trivial task, even just to determine whether a sentence expresses an opinion or not, let alone what opinion it expresses. And then to make it more complicated, there are some cases, plenty of cases, where things that are purely factual imply sentiment of one sort or another. So Amazon shares is going to be positive, at least it's positive if you work for Amazon or you're a shareholder in Amazon. How do we build a system to do this automatically? Well, there are several different ways, and the easiest way is really easy. You can do it in an afternoon, and that's why there are lots of sentiment analysis companies out there selling terrible software. You just collect lists of positive and negative words. They're out there. There are some on the web. You can also harvest them automatically by a fairly simple technique. You get a list of seed words, so 10 really positive words like great, wonderful, terrific, and some unambiguously negative words like terrible, awful, bad. Look at the contexts those words occur in. Go out on the web, find those same contexts in lots of places and see what other words occur in the context, and they'll very likely be the same polarity words. So you can harvest, you can bootstrap your word list semi-automatically. And then to classify a text, you just count up the positives and the negatives and make the decision based on that. A more sophisticated version of that is to use a simple machine learning method and train a classifier, get an annotated corpus of text, and train the system to look for particular features, which can be individual words or successive pairs of words. Here too, you can bootstrap the training data to some extent. You can harvest things like reviews, and particularly reviews that have a star system. A 5-star review is very likely to be positive. You can just label that positive, stick it in the training data, and a 1-star review will likely be negative, so you can use that as a negative data. And train up your favourite classifier. And that'll work reasonably well, but it doesn't. It has several disadvantages. For version 1, the simple lexical approach, what happens if you've got equally balanced numbers of positive and negative? You don't really want to say that the text is neutral. It's much more likely that it's a mixture of sentiments, and most texts are. Very few texts are wholly positive or wholly negative. There'll be different attitudes within it. Both of these methods ignore any grammatical structure. So a sequence of words like orders slump but profits rise, which I would take to be overall positive, that same sequence of words in a different order, orders rise but profits slump, which I take to be negative, and the difference is the grammatical structure. And that contribution of grammatical structure is very important, it turns out, if you want to get this right in a fine-grained way. So if you take a word like clever, that's pretty positive. Too clever, funnily enough, is not very positive. If you say that a plot is too clever, or his interpretation is too clever, that's not good. But then strangely, not too clever is also negative. And normally you can rely on not to reverse the polarity of what it combines with. So if you say that something is painful, not painful, is the reverse polarity. And then other things, like my favourite, a word like bacteria on its own, negative. Kill on its own, negative. Kill bacteria, that's generally positive. Failing to kill bacteria, well, that's negative again. Never failing to kill bacteria, that's positive again. Okay, so again, it's just the difference made by the grammatical combination of the words. If you're just doing word counting, you've got 4 words that in isolation are pretty negative, but putting them together in that configuration gives you something positive. So that's the way we try to do this. We try to do as full a grammatical analysis as we can of the sentence to try to uncover these grammatical combinations. This is by no means a solved problem. Okay, we get this right about 70% of the time on well-behaved texts like newspapers and so on. When you start talking about tweets and social media texts, the accuracy goes way down because, well, you know why if you've read any of them. The grammatical structure is often conspicuously absent. And then we have a set of rules, and the rules developed by the other guy involved in this company, Caro, who did a DPhil with me some years ago, and his thesis was basically developing this set of rules for English based on looking at corpora. And the rules say things like, if you combine kill with something negative, the result is typically positive. If you combine kill with something positive, the result's typically negative. Killing kittens is not generally regarded as a positive thing, and if you and killing neutral things is neutral. And then things about these individual words like that too. And we have lots and lots of those rules. That gets better results than the machine learning methods, at least so far, although the machine learning methods are getting more and more sophisticated, thanks to my colleagues who are rapidly catching up with us. But it still doesn't solve lots of problems. Words can have different polarity depending on their context. So a word like cold, in the context of beer, that's generally good, whereas in the context of food, it's not. Words like wicked and sick really depend on largely on the age of the person using them. So for me, sick is always negative, whereas for my son, a sick night out is a good night out. So you need to know the source of the text to be able to get that right. Also, we've only got the text. We've got no idea about the prejudices of the people reading it. So if I read something like oil prices are down, because I'm a motorist and I have central heating system and that kind of stuff, that's good. But if I'm an investor in Shell or BP, or if I'm in the government and wanting to take taxes, then that's bad. And finally, although lots of people claim to be able to deal with it, nobody can really deal satisfactorily with sarcasm and irony. So something like, oh great, they want it to run on Windows, textually is going to come out as positive because it's got a word like great in there. But any computer scientist will know that this is not positive at all. Okay, let's move swiftly on to deception. Over the last few years, I've become, I was really astonished to discover that you could detect whether people were trying to deceive you or not on the basis of some properties of text. And the reason I was astonished about this was because I thought, well, normally when you're trying to decide whether somebody's lying to you, you've got lots of different signals to play with. You've got the spoken language, so you've got the kind of intonation and that sort of thing. You've got eye contact, you've got facial expressions, you've got body pose, and the only work that I was familiar with on detecting deception was using all of these clues. There was some experiments done 7 or 8 years ago now, where they tried to see whether you could detect people travelling on a false passport in terms of their interaction with the border guard. Now this is not completely scientific because of course the people on the false passports were actors, but nevertheless they found by being able to take signals from speech, from gesture, they had video cameras and everything, they were able to train up a system which detected the fraudulent passport holders about 80% of the time, which is pretty good. Well, the baseline is 50%, okay, you just flip a coin. So 80% is quite significantly above that. But with text, you don't have most of that stuff, most of those clues. But it turns out that if you can collect corpora somewhat artificially often, where some of the texts are written by people who actually believe what they're saying, and others who've been told to put across a point of view that they don't necessarily believe in, then it turns out that there are some linguistic differences. So in particular, liars tend to they tend to be more extreme with their sentiment, extreme positive, extreme negative, lots of emotion words, and for some strange reason, motion verbs. I have no idea why that is. But the most significant thing is that they use fewer first-person references, things like I, we, me, our. What that seems to suggest, with truth tellers do use more self-references, and they're also very often more tentative. So they'll use, they'll exclude certain things from what they're claiming. They'll hedge it with words like maybe and possibly, and also, again, I don't really know why, lots more time-related words. So it seems to be that what liars are doing is exaggerating. He thinks he does protest too much, and put some kind of emotional distance between themselves and the content of what they're saying by not using first-person words, whereas truth tellers are happy to associate with the content. There's a great paper a few years ago in the financial literature where these people looked at earnings call transcripts. When companies reveal their profits, they typically have a session with analysts and often sometimes journalists to explain what's going on, because the shareholders want to know and other investors want to know and the regulatory authorities want to know. And these are, certainly in the US, they have to be transcribed and made publicly available. In the UK, I don't think that's the case, though you can usually get hold of them. So what they did was look at a bunch of these transcripts and then look at what happened in the next 6 months to try to work out which of the CEOs were lying, basically. So in the next 6 months, if the company restates its accounts, as Tesco did a year or two ago, suddenly finding that they'd made 500 million less than they'd claimed, or if they change their accountants, as frequently happens, or if the CEO or the chief financial officer moves on, that's a pretty good clue that all was not as it seemed in that transcript. So on the basis of that, they collected several hundred of these transcripts and were able to retrospectively label them as truthful or deceptive, and use those as training data to train up a simple classifier. And they were able, so the features that they used were the ones I've described: first person, motion verbs, all those kind of things. And they found that they could get something like 66% prediction accuracy. Again, not perfect. Again, the baseline's 50%. But if you are able to have that information, you can, well, in the best case you could make a lot of money, but in the worst case you can save yourself from losing it. So if you built a portfolio of the deceptive companies, typically the value of those companies went down between 4 and 11% in the following year, whereas the truthful companies either held their value or increased it. We built a classifier along these lines and put a lot of other stuff in it as well. In the education literature, there are lots of measures of readability and clarity of text, so we incorporated those as well. We've had huge amount of fun with this, using it on bankers' speeches, on company reports, and on politicians' speeches. The first set we tried was during the last general election, and we collected about 10 or 12 speeches each from Clegg, Miliband, Cameron and Farage, and ran them through the system. And I'm not going to say they were liars. Let's just say there was a very high incidence of indicators of deception present in those speeches. And I bet you can't guess who came out as the most truthful of those four. Well, on these indicators, it was Farage. And when you look at the text, you can see why, because he does not use complicated language. He just uses short, simple, straightforward sentences. So by all the measures of kind of clarity and lack of obfuscation, he, and also he believes what he says, whereas many of the others don't. We found lots of other interesting things as well. I haven't talked about emotion and humour yet, but one of the things we found was that if you measure the amount of humour associated with social media messages about the candidates, and David Miliband, 60% of the tweets about Miliband were classified by our system as containing humour. It was clear that the electorate just could not take him seriously at all. So let's go on to emotion. Emotion you can think of in some ways as a more fine-grained form of sentiment. There are lots of different theories of emotion. I could go on all afternoon about them, but the one we chose as a variant of, and most people do, is associated with a psychologist called Paul Ekman, 6 basic emotions which roughly correlate with facial expressions, allegedly. I think, and in fact studies seem to show that joy, sadness and surprise, yes, but the other 3, well, it's not quite so obvious. And actually it does turn out that there are cultural differences apparently between recognition of these emotions. Oh yes, I should have said. So Japanese and American subjects agree on the facial expressions for happiness and surprise and sadness, but much less for the others. And so this raises the natural question, is this taxonomy universal? And there are some really interesting examples in the anthropological literature. This one, this emotion Fargo, is, if that's how you pronounce it, felt when someone dies, is needy, is ill, or goes on a voyage, which looks like a negative sort of thing. But it's also felt when in the presence of someone admirable or when given a gift. So it really doesn't seem as if there's any word in English that corresponds precisely to that emotion. Of course, you've got to be careful here because there might have been translation difficulties. The other possibility is that, like many so-called primitive people, they were probably having the guy on. You know, they'll tell him anything he wants to hear and we'll get another packet of cigarettes. But nevertheless, it does seem that the basic dimensions of emotion are the same in all languages. We trained a classifier using data annotated by students in the linguistics department here, but also we used a lot of social media stuff because very often hashtags which started out as a kind of indexing device have turned into a kind of meta-commentary field on this, and they're quite useful classifiers of the emotion associated with a tweet. So we used that method to harvest lots and lots of data as well as using the annotated data. Okay, you're all politicians, so you're probably interested in how this correlates with election results, and there's been a certain amount of work done on this, and basically the story isn't correlate very well, really. There's been lots of controversy. There was a group in Germany who claimed that you could predict the distribution of votes in the German federal elections just based on the volume of Twitter, not the sentiment, just how many tweets about particular politicians. And volume very often is actually quite a good predictor of things, as you will presumably be finding with your Google Hits measures. So in particular for movie success, that was fairly roundly panned because it looked as if they'd rigged the figures a bit. In a group in Groningen found that tweet volume actually didn't predict the outcome of these Dutch elections, and that sentiment analysis was a better predictor, though still not at all perfect. They found some correlation in Singapore. A fairly careful study done by a group in Dublin found that you could find a correlation between tweet volume and sentiment with the outcome of the Irish general election, but still the error was greater than traditional opinion polls. You know, in a sense, all this is blindingly obvious, isn't it? Because the social media using public is not the same as the voting public. So why would you expect the two to correlate? What you can do, though, if you mix in detection of emotion along with detection of topics, is not predict what candidate people will vote for, but you can find out what it is that the public likes and doesn't like about particular candidate's stance on things. So this is a made-up example that for candidate Jones, people arouse strong negative emotions, his views on the economy and on immigration, but positive emotions on views on health and so on and so forth. A real example of this that we found again in the last general election was that among the party leaders, Clegg, the correlation, the Clegg's views on Europe strongly attracted anger in the voting public. They really did not like his kind of fairly extreme position on Europe, and it was interesting that I don't know whether they picked it up from, we were on the BBC about this, I don't know whether the Liberal Party picked it up, but it was clear that the weeks or two before the election he really toned down that stuff. So actually this would be, for a party political machine, this would be useful information as to, you know, how to not alienate quite so many people. Trump, of course, has done that splendidly. We've had lots of fun with this in the independence referendum. so it's a bit small to see, but the Stay campaign were scoring higher on sentiment about currency and the economy. Neither of them did particularly well on the EU. So this kind of correlation between topic and emotion is quite useful feedback. Again, this is a good story about why you shouldn't use this stuff to predict the outcome. If you looked at the volume of traffic on social media, the Leave campaign were all over it. They were very social media savvy. They dominated every rating, but of course they lost, because the majority of non-tweeters came out to vote. In the last general election, it's interesting to track these things and see how particular events can affect things. So here are spikes in this is positive sentiment towards the Vote Leave campaign. As soon as the campaigns were named, the Vote Leave came out. That's when the stuff about the NHS cash, the infamous boss with the 30 million a day or whatever it was on the side of it. Cameron on ITV really didn't help his cause at all. And the great debate on BBC, again, had the effect of making people more positive about the Leave campaign than they had been before. But similarly, the correlation of expressions of fear, of course not the same people, with Vote Leave went up and down, and people were much more afraid of the consequences of voting Leave than the Britain Stronger in Europe campaign. Here's another couple of examples. The Daily Mirror debate, which was almost a year ago now. Rather surprisingly, Peter Mandelson appears to have converted quite a number of people, because before that, in that particular channel anyway, there was quite a majority in favour of leaving, and after the debate it crept into the Remain category. The terrible murder of the Labour MP had a similar effect. So the views on immigration, the majority of people, when asked, will you judge, well, the way that we harvested this, the interpretation would be, if you were going to be voting just on the basis of this issue, which way would you vote? And lots would be voting to leave on the basis of immigration, but that crept back up after the murder, went back down again a few days afterwards. For all the topics, you find there are different things. So people were very keen if it was just decided on the basis of the economy, the majority seemed to want to leave, so on and so forth. This is here as a warning about how careful you need to be to interpret this, because we looked at that and thought, Scotland, 82% leave, but then when we actually looked at the text, of course, what they were doing was talking about leaving the United Kingdom, not leaving the EU, which makes much more sense of it. But it shows you've got to be really careful in filtering the text to show that they're relevant to the dimension you're trying to measure. We're still monitoring Brexit just for fun. I took a snapshot this morning. So views, there aren't very many. This is the volume is quite small. So just 500 over the last week. Things about Article 50. This is in the press and in social media, but it's broadly positive about Article 50. But hard and soft Brexit are strikingly different. So there's no positive comment about hard Brexit out there in the press or social media, surprisingly. But again, quite small volumes. But with soft Brexit, there's no negative comment out there. So really striking polarisation. But again, tiny volumes, okay? 20, 30 documents, nobody's really talking about soft Brexit. Okay, let's stop. I'll stop there. So, summarise what I've said. We can detect surprising number of signals, not incredibly accurately, although we're getting better and better all the time. The accuracy is a worry, but the hope is that because you're processing huge volumes of text, so we've seen not just now, but in general, these figures are based on millions and millions of examples. So you'd hope that the quantity means that there really is some signal in all that noise. We know that sentiment has a predictive value in many areas, particularly in finance. Emotion classification likewise does, and I think there are lots of applications for this in social sciences as well, which is why you're all here. Text is, in that respect, an underused resource. There's lots of it. There's more of it out there than you can read, but if you've got tools to give you the gist of what there is out there without you reading it, then that's a useful source of information for you. And the other interesting thing that's starting to happen, again, particularly in finance, but there's no reason why it shouldn't happen in social sciences as well, is the combination of these text signals with other numerical signals, sort of voting numbers, financial indicators, economic indicators. Very often the correlations to be found there can be quite revealing. Okay, I'll stop there and hand over to Scott.
Great. Well, I didn't know, I guess, the entire scope, and I thought if I was talking about text processing, I should take a different stance and just switch to a slightly different method. And I use both in my research, but I thought it'd be useful to think about relationships and how we can structure these in a network sense and think how things fit together. You'll see some echoes of text analysis and language, computational linguistics in this research as we go along. I'm going to try something that I haven't done before, but I've taken two different sort of lectures and put them together and tried to keep the interesting bits to give you both an introduction to sort of network analysis and what it means as a method, and then also show you some of its application in work that I do, particularly thinking about bilingualism and connections between speakers of different languages. So quickly, as I was introduced, I'm coming from the Oxford Internet Institute. We're a multidisciplinary department of the university, broadly studying life online. Lots of scholars from social science backgrounds there. Myself, I'm coming from computer science, but almost all of the applications and what I'm working on are applying these methods to social science questions, and in particular, collective action mobilization and multilingualism are two of the big areas of application of my work. So networks, what's the big deal? We've had surveys, focus groups, interviews. You have all these traditional methods, and what's changing? Well, the big difference here is that rather than asking questions of every individual in sort of an atomistic perspective, what we try to do with social networks is think of it in taking in this whole social context, understanding that people are connected to one another and that those connections have value to them. They influence each other. And it's not, drawing out these social network diagrams and things like this isn't to say that that these are exactly the connections and things work like this and that you are in a network, but rather that these are a tool that we can use to try to represent these contexts, and then we can apply tools, apply statistical analyses to these representations, to these connections, to understand what influence they might be having and how the micro level connections between individuals relate to sort of larger scale macro level outcomes. And there's a lot of great classic findings in network analysis that I think will make sense to you. So this idea of weak ties. This is Granovetter. If you think of where do you get novel information from? If you're searching for a job, is it going to be amongst your close friends that you find that job opportunity? Or is it going to be amongst an acquaintance, someone you see only occasionally? And Granovetter's hypothesis and confirmation in his empirical work was that actually it's among those weak ties, that acquaintance who you don't see so often, because most of the time your friends all have the same information you have. they're consuming the same things, you're talking to lots of the same people, and it's that acquaintance that you see only occasionally who has different information and new things to introduce you to. And that's a direct sort of corollary to this idea of homophily, that similar people group together. And yet, despite these sort of things, or perhaps because of both of these phenomenon, there's this idea that we are also not all that separated from each other, and in many networks, the actual longest distance between any two people is something about 6 intermediaries. It varies by platform, but even if we think something like Twitter, which is an example I'll walk through in a moment in some of my work. I mean, yeah, okay, there's weak ties, that person you followed, you met at a conference and you never really otherwise interact with. But, for the most part, there's a lot of homophily. How many people do you follow that are at Oxford or within your discipline, as opposed to those who are outside of Oxford, outside of your discipline? Or, how many do you follow in your primary language versus those you don't follow language? And yet, if we look globally across Twitter, we still see an average path length of something like 5 connections between any 2 accounts in the network, which is remarkable if you just think about the scale of this network. And so, networks can be really useful to show these contexts. And just a bit of terminology. So we have sort of entities. In my case, they're going to be individuals or accounts on social media. And so we'll call those nodes or vertices. And then we can connect them together with edges. And those edges could be linked. It could have directions to them. In which case, like Twitter, I follow you, but you don't follow me back. Sort of thing. Or they can be undirected. Facebook, we're friends or we're not friends. It's just a yes/no binary there. It can't be a one-way relationship. And we can think about other ways that networks work. So, yeah, as I was saying, with this sort of representation, then we can start applying some measures to this. We can ask how far apart different parts of the network are. Are there some people in important positions, either because they're very well connected to everyone else, or because they're at a point where if you would take them out of the network, it would basically split apart, that they're sort of a crucial bridge between different clusters of the network. And then we can relate this to processes in the social sciences, talking about how information spreads, etc. So I'll skip that. Yeah, I have a couple slides here that just, if you go in, you say, I want to try this out, what are we talking about? Well, you first just need some data, list of your entities, and a list of your connections. Maybe they have some weight to them. And the simplest way is just comma-separated values for these, sort of spreadsheet style. And you can bring that data into something like Gephi, is a popular open source platform for visualization. Or there's slightly higher entry curves, but packages like iGraph for R, and Python actually, or NetworkX, particularly for Python, that will allow you to do much more analysis of the data within this network structure. So the example I'm going to spend the most time talking about and trying to apply some of these network methods to and convince you that this is a sort of nice context to apply them to is bilingualism. And particularly thinking that other studies have shown there are large differences in the content available in different languages. And so I think particularly if you're an English speaker, you just think there's a lot of content out there and it's all in English. But if you're a speaker of a smaller language, it's usually immediately apparent that there's just not every answer in your primary language. And actually even within English, there's a lot of content about particular regions, about particular applications that isn't in English. And so the question is, how does information spread between different languages, people speaking different languages, particularly thinking about social media, and thinking about the idea of what bilingual people might play, and are they sort of these connections? Because we have this conundrum, if you'd like, that, as I said, the network on Twitter is very well connected between any two people. There's a short distance between them. And yet, we also know that there's a lot of clustering. People mostly just follow those people in their language, and only about half the content in English is on Twitter is in English. And so how can we have these two things? Short global path lengths, and yet very much within language clustering. There must be some users who are bridging across these different language clusters and having that effect to be able to keep these short path lengths. And my question is, are they bilinguals? So if so, what are they doing? And along the way, we can look at some of the linguistics knowledge. So bilingualism is quite common offline. It's actually not so common online, which we'll see. But as I said, there could be these sort of benefits of novel information relating back to this idea of weak ties. If you can take information from one context, perhaps one language, and introduce it into a different language, that can be new, novel information, and a lot of the social science literature supports the idea that this is important for innovation. So the network I'm going to talk about comes mostly from Twitter. It's a 1% sample of the network captured over a number of months. And we have nodes in this network as Twitter accounts. Lots of challenges with this, of course, that not all Twitter accounts are humans. To begin with, my question was mostly interested in sort of coming from the social science side, was interested in humans, so we've tried to filter this to get rid of any automated accounts, and that uses some of the computational linguistic techniques that we've just heard about. Bots are much more predictable than humans, not only in the type of language that they use, but also in the patterns of timing of when they post and what they post about. So we can filter out, not perfectly, again, but many bots and try to restrict ourselves to human actors. And then we can look at how they mention and retweet one another. Who are they interacting with? And we can find, through the statistical methods, these automated clusters, groups of the network that are very much connected internally, but there's few connections externally between these clusters. And what I'll do then is look at the language that people are using. So English, Spanish, German, Japanese. What is the language that they're primarily using, and how well do these map onto clusters? So here I have a cluster that's entirely in the orange language. Here I have a cluster that's kind of blue and green speakers in that cluster. And so this is a toy example. I can't visualize the entire Twitter network because there's more accounts than pixels on this screen. But what I can do is give you some of the summary statistics here, right? And so I can find these clusters, found about 20,000 of them. It's about 1 million Twitter users, break into about 20 clusters. Many of them are small. There's a few that are quite large. And overall, almost all of these clusters are composed of groups of users who all have the same most common language to them. It's about 70% of the clusters fall into this category. If you want a baseline for what that would look like, so if we kept the same distribution of languages, same network structure communities, but we just shuffled up the languages, we just swapped languages randomly between people, we'd expect this baseline to be about 0.5%. So we see 70%. So this is far, far in excess of any random baseline that you'd expect. And so we know that the network is heavily clustered by language. That makes sense, right? And I sort of said that's probably given. So then the question is, do bilingual people sit at these intersections between different linguistic clusters? And so what we can do again is try to identify the accounts where people are using multiple languages, where they're writing posts in different languages. And I should also just pause here again and nod to the computational linguistics side of this to say that we do fairly well at detecting language, even in social media content, but it's by no means error-proof. Particularly, as Stephen said, there's a conspicuous lack of grammatical structure at times. But we can still identify perhaps above a certain threshold, which is what I've done here, to say those users who consistently are using more than one language, and then ask what happens, and here's where I'm using this network sort of toolkit, is to say what happens if I take those users and I delete them. And I want to measure how the network looks beforehand and compare the statistics to how it looks afterwards, right? And here I have one component, if you'd like. The whole thing's connected, and I there's a link between somewhat two nodes. I could somehow find a path. If I delete these two nodes, all of a sudden it breaks into two parts. I have this part here, no links at all now to the part below. And so we can do that similarly in the data at scale. And, oops, no, there we go. And I can look at a number of different outcomes. And one of them is, I'll just quickly say them and I'll just walk you through in one in more depth. One is the size of the largest component. So this largest part that's left over, what percentage of the network is it? How big is it? The number of components, how many different pieces did it break into? And then the average size of each of those pieces, excluding the largest one, to ask whether we just sort of disconnected 1, 2 users here, or do we dump off a big part of the network? And in all these cases, what I've done is removed either the multilinguals, who are about 10% of the network, or removed an equivalent number of monolinguals chosen at random. Done that 100 times to iterate, and so we have a distribution there of what that would look like. Or removed users completely at random, regardless of whether they were monolingual or bilingual. And I'll just zoom in on just the size of the largest component. So if we think, if multilinguals do sit at these bridging components, at these bridging places, if we remove them, then we expect this network to fall apart into more pieces, to fracture into more parts. That's the number of components. And that the remaining portion, the largest portion that's left, should be smallest in size. And that's indeed what we see here. So here's the size of that largest part that's left. And for multilinguals, it's significantly smaller than if we remove an equivalent number of monolinguals from the network. And sorry, since I gave the introduction to the number of components, the opposite happens, right? If we look at the number of parts it breaks into, the multilinguals break this network. Removing multilinguals breaks the network into more parts than removing an equivalent number of monolinguals or removing users completely at random. And of course, we can start breaking that down and ask about different languages. And so you're saying, hey, I'm an English speaker. I feel important. You know, I know half the content on Twitter is in English. And yeah, you know, removing English speakers from this network breaks the network into more portions. And we end up with more nodes disconnected from that largest component compared to any other language. And in fact, what's quite interesting is that actually, depending on your account and your data source, Japanese is among the top languages on Twitter, either the second or certainly within the top 5. But in contrast to English, which has many connections to other languages, Japanese is almost entirely insulated and mostly connected to other Japanese speakers. And so removing all of the Japanese speakers from the network actually has only a little impact on the rest of the network. Portuguese, Malay, Dutch, Spanish all have more of an impact. I should say, however, that all of these numbers are smaller than removing the multilinguals from the network. So even though there's many, many more English speakers than multilingual speakers on Twitter, actually the multilingual speakers are still more often in these bridging positions. So, and I said I couldn't show you the entire raw data because there's simply too many data points, but I can start to represent these and just collapse people to their primary language. What's the language that they use most often on Twitter? And then how are these languages related to one another? And here we can see, for instance, that English is central in this network, but it's not. In general, there are connections between almost any two languages you'll find. But if we look at how strong those connections are, there's lots of languages where there isn't a strong connection. And then there are places where there are more strong connections between, say, Romance languages, Portuguese, Italian, Spanish are all well connected here, or geographic areas. Japanese users mentioning a lot of Korean users, for instance, and having spent a good amount of time in Japan, my conjecture is that this is about Korean drama, which is your sort of your soft power, maybe, in IR if you'd like. But what is it that people are reaching across borders for? And so, using this sort of approach and looking at these connections, I can now say empirically from the data that people do cluster quite strongly by language, but that bilinguals are sitting in these gaps between languages, and that they are sort of these critical connections that if I remove them, the network starts to fall apart. Now the question becomes, they're in the position, but of course network analysis doesn't tell me at this point anything about what they're actually doing. Are they communicating the same content across languages? And this would be important to think about innovation or novel information. What does it mean if they actually take something from one language and tell their friends about it in another language? Or is this just context collapse? Are they just talking about completely different things in their different languages, and it's just happenstance that they have chosen one Twitter account, and they might as well have actually just had two accounts, and they're doing completely separate things in different languages. And there's some linguistic reason to expect that we might see quite different things happening in different languages, and just in the fact that often language is a part of the context of our lives. So we know from linguistics, people have their schooling perhaps in one language, and they have more cultural things or other events in a different language, and generally they just stick with those languages, and they'll actually find it difficult to use the other language. So even if they're a native French speaker, but they've had all their education in English, they might find it actually quite difficult to give an academic presentation in their native language because they've had the experience of academic pursuits, if you like, in English, and it's easier to do it in that language. And experimental evidence of asking people to recall situations in different languages, bilinguals, also shows this similar idea. This was, I think, Russians, bilingual Russian-English, and if they were interviewed in Russian, they could remember things, life events that happened in Russian more easily, give more vivid deep recall, and vice versa for English. So one challenge to ask about what people are doing then is to identify topic or to find similar text in different languages particularly. And Twitter is difficult. This is an area where I'm still working on in trying to identify similar content in different languages on Twitter. But an easy, low-hanging fruit approach to this is to jump over to Wikipedia, which is one of these great text resources for all sorts of computational linguistics. And of course, what we have on Wikipedia is not parallel translated articles, but we have some sort of related articles in this language links that are along the left side. If I go to Barack Obama's article, and they're not going to be word for word the same, but they're going to be an article about Barack Obama. And so I know that topic is similar, and this is often useful for identifying things in different language texts. You can sometimes even cluster to a Wikipedia article and then use this inner language structure to find similar topics across text. Across languages. I'm going to do something even simpler, which is just to look exactly at the editing pattern on Wikipedia with respect to how similar articles exist across languages. And what's remarkable here about what bilinguals edit is that there's two distinct editing strategies among bilinguals on Wikipedia. So those who are editing more than one language edition of Wikipedia, about 15% of Wikipedia editors, and a good portion of them are editing completely different things in each language. So they edit sport in language 1, and they edit politics in language 2. On the other hand, there's a different strategy, which is the other bar at the far end there, which is, basically I'm editing the exact same articles in all my languages, and you'll see that there's not too many people between these two different strategies. I should a slight clarification on this graph. Of course, not all articles exist in all the different languages. There's, again, big gaps in what's available in different languages. So partially this bar is very large because people are editing things that don't exist in the other language that they also edit. If we take that out and we just look at the articles that exist in all the languages that a person edits and look at their distribution, we still see these two categories, but they're about half and half. About half the people editing completely different things in each language, about half the people editing similar things in each language. And so I think a real challenge here is to how bilinguals can find out what is relevant content in another language and how do they become aware of that content and discover it. And of course, there is an active field of sort of cross-language information retrieval, but often that's built with the idea of sort of someone actively querying a set of other languages. They already know they want to find a certain document that's in another language. And I think the challenge for interface designers and sort of where I'm at in computer science is thinking about how we build systems and how we design interfaces for people, thinking about particularly multilingual people and how we can maybe serendipitously help them find that related content they wouldn't know they had to go search for. And so I'm thinking about ways we build interfaces for that, and I'll come back to that in a moment. But I'll zoom back out from this example and just talk more generally about networks quickly. And so we have lots of these different statistical measures, and I was talking about number of components that work at this network level or the size of the largest component, but we can ask things about density and how many connections there are observed versus the number possible, how well it clusters, what's the path length look like, and then also with any sort of individual node, individual person, we can ask about how many connections they have or how central they are in the network. And this idea of centrality is quite interesting because it's not just popularity. I mean, that's one option, degree, but really perhaps what we're getting at with the bilinguals in my example is really about betweenness. How much do they sort of rely on these points in the network that if I want to trace out a path between other people, I'd have to go through that bilingual person? And the answer seems to be quite a lot. It turns out that actually calculating betweenness is a very expensive process computationally. And so it's actually very difficult to calculate that directly for the network I had, which is why I showed you this sort of experimental approach where removing those individuals and seeing what happens. So back to the example and just thinking about what are the sort of social science implications of this. I said that bilingualism is the norm if we look at survey evidence, but that doesn't appear to bear itself out online if we look at behavioral evidence. And my conjecture for that is there's a lot to do with interface design and discovery. I don't have time to talk about that work, but that's a whole different stream of work, a related stream of work that I work on. But we can detect some of the sort of things you'd expect to find from linguistics at different levels of competency in different languages. And ultimately, we can say that bilinguals are important. They're a small size group relatively, 11, 15% in different platforms, but they give large contributions in their first language. And if we look at, say, in Wikipedia, what the content they contribute is generally kept along. It's not immediately deleted or reverted. That content tends to stay and be incorporated. So their contributions seem to be valuable. And yeah, we can dig into the types of contributions, other things they make, but there's sort of different types of contributions that people often make in their different languages. And as I said, there may be mixed evidence as to whether they actually serve as that bridge because, well, they're in the positions. Only about half of them are editing, say, on Wikipedia at least, contributing content, similar content in both languages. Otherwise, they're doing often very different content. And if we try something like topic modeling, LDA, on Twitter, we get similar sorts of ideas that there's a group that are talking about very similar things in different languages, and a group that are talking about very different things in the different languages, about half and half, again. And so this is my nod back again to computational linguistics to say that everything I've showed you here, well, using the tools of network analysis is also relied on sort of extracting this structure from unlabeled data, unstructured data. And multilingual topic modeling is still an area of active research. So we do very well sort of on language detection in the whole. There's room to be improved, certainly. But there's also a lot of code switching that happens in substitutions on social media where people will borrow one word from a language or they'll combine two different languages together in a single tweet. And that just causes all sorts of trouble, at least with the methods that I've used to date. And so sort of word level language detection, and also minority languages are an important area to study. And identifying this sort of similar translated content across languages, again, is an area of research. Working on it in, if you'd like, from the computational linguistics side, we might think of maybe this sort of as being computational social linguistics, if you'd like, which is a term that Dong Nguyen and others have coined recently to say it's sort of these applications to what would traditionally be in the linguistics or sociolinguistics area, but trying to do that using these new methods and tools. And where do we go from here? I said some of the things that I try to do are working on actually improving the system's interfaces. So the research that I presented and some related research on Wikipedia was incorporated into a translation tool developed by the Wikimedia Foundation to help ease the process of discovery of articles that didn't exist in a user's target language, and provide an interface that can help them translate those articles by taking care of some of the overhead of the links and the images and additional things, and letting the person just concentrate only on translating the actual text of the article. I'm also working with a startup in San Francisco, again, on building tools that could help people who want already to share content across languages, but they want to make that content more accessible so they can follow their celebrities in one language, and they'll translate and retweet them, and they can work together to provide sort of that coverage. And again, this seems to actually be something that people already want to do if we give them the tools and give them the options to do that. So just a couple resources on networks for you to delve into if you're interested in going further in this way, and just, yeah, an encouragement. I think that I think there's a good amount that can be done by taking this sort of relationship approach and understanding the context that people are connected with and what that means for the social science questions and processes that we study. So thank you.